All right, next up we have Ochibobo Warren, who's going to tell us about ORTools.jl, bringing Google's optimization power to Julia. So Ochibobo, please take it away.
Thanks a lot, man. Hey, I'm going to be talking about the ORTools.jl package, which is like a new package that tries to expose Google solvers to Julia. But a bit about me, I'm joining you guys all the way from Kenya. That's in East Africa. It's my first time in JuliaCon, my first time giving a talk. I'm really humbled to be here. Currently, I've really learned a lot. I like the pursuit of knowledge, especially with respect to science and computing. Currently, I work as a software engineer in Google, in the Nairobi office also in Kenya. I work in the Android team primarily. So what I'm presenting here served as we have this concept of like 20% projects, which is what you get to work on when you're not working on what you are hired on. And given that I'm a Julia enthusiast, this seemed like the thing to go. So I'll just get started. So ORTools.jl in general is basically a layer, think of it as a glue, on top of Google's solvers that tries to expose the interface of Google solvers to like the Julia community. And then that glue also glues another interface that's present in Julia known as MathOptInterface, so that now you can use, there's a package called JuMP. You can use JuMP to actually do your optimization work using Google solvers. It'll be very easy. So let's just get started. So the agenda, the steps I'm going to follow is, of course, I won't assume knowledge in mathematical optimization. So I'll start with a brief on that, then a brief on MathOpt. So MathOpt is like the interface that Google has on top of the set of solvers that it exposes. Then I'll talk about the bridge, which is like the primary, like the objective of the talk, which is the ORTools.jl package, a simple coding example to show you like the effect of having JuMP on top of like MathOpt and how the code is actually reduced. Then finally, use cases and applications, and I'll finish my talk with like an opportunity for Q&A. So my background is not in operations research, which is where, okay, from what I've seen, that's where like mathematical optimization is pretty much dominant. My background is in like computer science. So in computing, when you have a problem, what you do is you get the input, you try and design the algorithm yourself, after multiple iterations to try to get an output. What I've seen in OR, in operations research, is that people actually use this thing called solvers. So you get the same input, you define your problem in form of like a model, meaning you have to have like some knowledge with respect to that, feed it into a tool called a solver, and then you get an output, which is kind of amazing, because then you get to have a tool that solves not just one problem, so what an algorithm will do, but a class of problems. So math optimization is the science, think of it, it's just a science of making the best decision possible using like while respecting like a certain set of constraints or limitations that have been imposed to you, either physical limitations or real world limitations. The world has limits. So the goal of any mathematical optimization thing is to probably find the best solution to whichever problem you're trying to resolve, or even finding a solution if the problem is to deal with feasibility. The choices you make are going to be represented as variables, and then the limitations that are imposed on your problem are known as constraints. So the core things when you are working with solvers, in a general sense, you'll have to obviously define your decision variables, the thing that you want to make choices on, the constraints that you are facing, like the limitations that you have, and then finally the objective function. Like, are you trying to minimize something, maximize something, something of that sort, or are you just trying to find a feasible solution? So these three things primarily make what we call like a model. So a slight thing about how I ended up in MathOpt. So how I ended up in optimization. Initially, I used to work for like a logistics startup that's based in Kenya. When we were doing a bit of research with respect to how we can solve some of our problems, I came across the idea of like solvers and stuff. So that was about 2 years ago. I tried to like write my own constraint optimization solver by implementing a paper called MiniZinc. It's actually free online. The goal there was to just do it for pedagogical purposes, to learn how you can actually write these tools before starting to like use the already existing tools in the market. It's quite a learning experience, I have to tell you that. The package is actually online. It's not registered. It's not part of Julia registry, but it's on my GitHub. I think with a couple of stars. I've tried to like document things on the README. It's kind of a huge one. Yeah, so that's more like it. Then I joined Google. Google has a set of solvers, a couple of them, some that they own, some that they do not own. But they want to expose and use one within Google and also expose the general audience. So Google has this thing called MathOpt. So MathOpt is just an interface that Google has defined that acts like a layer on top of a set of solvers that help you to solve or define and solve your problem in a way that is solver independent. What do I mean? So they're existing in the context of solvers. There are like multiple solvers that do exist. So what MathOpt does is it allows you to define your model independent of knowing which solver you're going to use. And then eventually you can just feed that model into different solvers. So how you define your model is independent from it's independent from the solver that you'll use. But eventually there's kind of a guarantee, a contractual guarantee, that if the solver is being exposed through MathOpt, then you'll probably have a solution, or at least you can actually run it against the solver. These are the set of solvers that the current MathOpt implementation exposes. You'll notice that there are three that are predominantly starred. That's the CPSAT solver, there's the Glop solver, and the PDLP solver. So these three are like Google-owned. The others like Gurobi, Skip, GLPK, HIGHS, or HIGHS. These are solvers offered by other, let me call them organizations. Some are commercial, some are open source, but they still get a space of being exposed through like the MathOptInterface. So let's just go to the next slide. Julia, as of today, there wasn't a way of accessing Google solvers through a Julia interface. Of course, Google has this tool called ORTools. We won't assume you guys are familiar with it, but ORTools currently offers support for Java, C++, and I think Python. And that meant that if you were accessing the solvers exposed from Google, you could only do that using those set of languages. If you want to do it via Julia, you'd have to find a way to either write a wrapper on top of the existing language or something of that sort, just tweaking things on their own. So the diagram at the bottom exposes the architecture of ORTools. So the top package is the ORTools layer. What that does is, okay, let me start with the bottom two. So the first one is ORTools generated. So ORTools generated contains a set of, a set of structures that map to the protos that are exposed through MathOpt. So the ORTools generated, these are Julia structures that are generated from the proto files in MathOpt. For those who don't know proto is just it's a data format that's used for serialization and communication over a network, something of that sort. They're very, very predominant in Google. That's what's predominantly used. So what we did is we got the set of protos in MathOpt, then used protobuf, which is a package used in Julia, and exposed the protos in Julia structs. So Julia structs that map to the protos. And that also comes with a set of functions to correctly serialize and deserialize any proto message that you send. And ORTools, the JLL, that consists of C functions that call into the underlying C++ functions. Most of these solvers are actually implemented in C++. So once you have your ORTools, once you have your proto file, you feed them to the solvers that are in C++. So we needed a wrapper on top of that. So we have the ORTools, the JLL wrapper on top of it that we feed the proto into. Then the ORTools.jl just acts as a glue in this way. One, it acts as a glue on top of the ORTools generated files, these are the set of protos, as a glue on top of the JLL, which are the C functions that we call using CCall. Then it's also a glue on top of the MathOptInterface. MathOptInterface is an interface or a package that's defined in Julia that tries to expose a set of functions or APIs that if you implement them, you get a guarantee that your solver will actually be accessible through JuMP eventually. So this is just a basic example that I wanted to show of how you can use ORTools.jl in its pure form. So you're maximizing a profit from producing two products, X and Y. Product X gives you $10 per unit, Y gives you $15 per unit. Then you have a set of constraints where you have 100 available hours in labor, where product X takes 5 hours per unit, Y takes 10 hours per unit. And the materials, you have 120 unit materials, where product X takes 8 units and Y takes 6 units. So how will we do that in ORTools.jl in its pure form? So, okay, this is just like the LaTeX representation. Try and condense all those words into just a simple representation that makes it a little bit clearer for like guys to understand. So the first thing you do is you import the ORTools. You initialize your model using the ORTools. It's called an optimizer, ORTools.optimizer. You define your variables. These are X and Y and stuff. The next thing is you define your constraints. We had labor constraints and cost constraints. We also had constraints to deal with both variables. You'll have values greater than 0. That's there by default in MathOpt, but then I didn't want to assume anything, so I just had to define it there. Then finally, you define your objective function. We're trying to like maximize our profits here. So you define your objective function in this case. You can actually print out the model, and then you also call like optimizing the model, and then when you print, you'll get like your solver results and stuff. So as you can see, for such a small problem, we've ended up defining like a lot of things. Like this is a lot of code for such a small problem. But the thing is, when we actually interfaced with MathOptInterface in Julia, we got exposed, or at least we got to satisfy the conditions that are probably needed to work with JuMP. So JuMP is like a common Julia package that you'll find being used mostly in like the optimization, or in mathematical optimization scenarios. So JuMP is just an interface in a certain sense, but it greatly reduces the code that one has to write. So from those 3, 4 files that we had, the same model can be defined using JuMP. You can see that the variable declaration becomes very small. The constraint definition becomes very short. The objective definition becomes very short. And I'm using just crude terms here. And this is such a basic example. You call the optimizer the same thing. Then you can also obviously print your results and whatever. So the good thing now that you have ORTools, it means that in the same way you would access solvers using like JuMP, how you'd access Gurobi and whatnot, it's the same way now you can actually have access to like Google-defined solvers. The optimizer, the ORTools optimizer that's present here, that's present there, allows you to define parameters with respect to which solver you're going for. So are you going for like the PDLP or CPSAT, or are you going for Glop or whichever? Yeah. Then a few examples of how Google uses solvers. I provided links so that it might be easier for like guys to just go through them instead of me explaining them. So you have like the workforce scheduling API, you have a shipping network design API. You're not just scoped to this. When you go to the like ORTools site, every example that's present there in like other languages can also be accomplished using like the Julia language now that ORTools is present. Then how Google uses the solvers, mostly it's for resource planning, resource and capacity planning in data centers. Then real-world applications, this is in a broad sense. You're not just scoped to this. You can use them in logistics, as I told you, that's where I started off, in scheduling, in finance, in energy, and in many more, depending on how you'll actually define your problem and whether the tool actually fits the bill. Then, a bit of the hurdles that we faced while we were working on this. So, when I started off, I didn't mention who I also worked with on this. His name is Steve Out. He works at Google, but he works in the operations research team, so he's more aware of the solvers than I am. But it was more of a collaborative effort at the end of the day. So one of the hurdles that we faced was the MathOpt interface is it's a large interface. Like there are a lot of things that you have to implement, that you'd want to implement in order to like in order to like expose everything that's present in your solver. And it also comes with like a set of tests. So sometimes you implement things, you run the test, your tests fail. Sometimes the tests pass. So it was kind of like a back and forth, but the interface is quite large. Though it was both an enjoyable and hurtful experience. Then the second was the protobuf.jl package. Protobuf currently, when you generate like Julia structures from the proto data format, it assumes immutability, or the structs that are generated are actually immutable. So it's just struct, then the struct's name. You don't have the option of generating mutable structs. So when we face this hurdle, because we have structures that actually get updated as you are defining your model, for example, the model itself is a structure that gets updated as you define it. So I tried to like open up, to reach out to the maintainer. It wasn't kind of easy to even find who was the current maintainer of the package. Then eventually, after getting to the by the time we were getting to the maintainer, time had already gone. So what we had done is we had written like mutable wrappers on top of our existing structures, which just made the process longer. But now I have like a PR at least that will try and add like the ability to specify that you need mutable structs to be generated from a particular set of properties. Then the JLL wrapper, I remember this took a long time. I didn't particularly work on it. This was work that's primarily done by T-Bout. Yeah, that's all I can write there, because it took a long time, so I'm sure there were kind of hurdles that he faced. So what are the next plans with ORTools.jl? Cool. So currently the one solver that we support fully is like the Glop solver for linear programming problems. But we need to complete the support for PDLP, offer public documentation with examples, of course complete the support for like the CPSAT solver for like integer problems and constraint problems. Then there's this thing where we want to add like support for remote solver calls. So when you install the package currently, you'll have the package running and like solving the things on your machine. So we'd want to allow you to, yes, call the package locally, and then, yeah? Oh, okay. Yeah, so we'd want you to be able to like have Google servers do the solving for you. So if your model is quite huge and maybe it'll consume a lot of machine resources, you can just send it there. Just post your like model to Google servers online, then they'll do the solving for you. Currently, we don't have support for quadratic optimization problems. We'd want to add support for multiple objectives. And our goal is to have like the first major release in September 2025. So currently, we do have like the JL package. I think it was merged today, ORTools.jl. But I define that as like the alpha version. So on September 2025, because we also want the package to be ready, one for the JuliaCon that'll be in Europe and the other one, and for JuMP, like the JuMP DevCon that will be in New Zealand in November. We want the package to be ready and also battle tested. So expect the first initial, like major initial release by September 2000, of course this year, not 2025. Yeah, and that's all about it, man. That's all about me. The package focused more on the layer, not on the solvers, because I never wrote the solvers, not really fully aware of how they work. But if you have like concerns about them, you can reach out to me and I can obviously try and like find someone who will really help you out. So thanks, that's the end of my talk. Cool.
Well, thank you for the talk. I think it was very interesting to see this, being familiar with JuMP and everything. And I was curious about maybe Google's vision or your vision, your team's vision on how this integration helps you, given that some of the solvers that are available through ORTools were already previously available through JuMP. So you see any performance gains in the sense? How does that compare? And also, how you see this being used in JuMP, especially the solvers that are related to constraint programming, because this is something very recent in JuMP, so I want to see how you use them.
Cool. Awesome. So the first question was with respect to the gains that we have by having this. Cool. Yeah. When you look at and you're right about other solvers already having like existing packages in Julia, like Skip has its package, Highs has their package and stuff. So yeah, these solvers will also be offered through like the ORTools interface, because they're also offered using Google, through Google. But then the three that we are predominantly focusing on were like CPSAT, Glop, and PDLP. I've had a lot of interest with respect to like the PDLP solver, especially if you have like a large, if your model ends up being large. Of course, the trade-off there will probably be in terms of maybe the model accuracy, something of that sort, but you will probably get a solution with respect to it. So the gain here will be, one, we are exposing our solvers to the Julia community, and the Julia community has like a very, very solid presence when it comes to mathematical optimization, especially through JuMP. The other gain is, okay, this is just my perspective, probably looking forward to PRs. So when it's open source and stuff, and you have this engagement from people who have experience in a particular field, but in a way that's not unique to Google, at least incorporating the ideas into improving the tool will not only improve the tool for Julia, but also improve Google's tool in general. Yeah, have I answered your first question? What was the second one, kindly?
The second one was more about CPSAT, GLOP and PDLP, and your experience with the new JuMP interface for constraint programming. Because Julia, in JuMP, you usually do linear programming, quadratic, and conic was very well established, but the interface for like set problems is quite new.
Oh,
so
okay.
I wanted to see
Cool.
What's your experience with that?
Awesome. I didn't know there's a new JuMP interface, to be honest. So, okay, because currently the implementation we've only done completely for the linear programming bit, which is Glop. I think that's why I haven't come across like such things. But the good thing with like the MathOpt interface is we found it to be very extensible. So if there's if there's missing support for particular features, even in our current implementation, we just extend some abstract thing. Of course, we try as best as possible to offer a clear definition with respect to, hey, this, like a clear documentation, this is how we use this structure and whatnot. So I think we'll be able to, especially for the CP-SAT things. I know there are things that are unique, like in the SAT world, for instance, like constraints like all different and something and things in that line. I didn't know they were new. I thought they were there initially, so I'll probably have to look into the new bit. I wasn't aware of that, but I think we'll make do with it. Yeah. Cool. Thanks, man. Thanks. Yeah.
Thank you very much. Thank you very much for your talk.
Awesome, man.
And I also couldn't imagine giving this talk with the amount of jet lag that you must have, having traveled all the way that you've traveled here. So I've got a couple things I'm curious about, but let me ask about one of these. So all of these solvers, some of which were developed by Google that you have highlighted there, for folks at Google who make use of these things for doing OR work of various kinds, you are a Julia enthusiast in a jungle where there are probably some other Julia enthusiasts and probably some who are not.
Correct.
What kinds of interfaces do a lot of your colleagues use who are not Julia enthusiasts to access all of this stuff? And have you had any conversations about trying to convert people to Julia? I'm kind of curious about the range of practices that you see to make use of these tools right now at Google.
Okay, in Julia or the tools in general?
The tools in general.
Cool. So what I've seen, okay, I don't work in the operations research team, so I'm speaking from like a external perspective. Yeah. So what I've seen is there've been some efforts, especially with guys from the OR team, to try and reach out to members of other teams, like in Waymo, for example, to try and get them to use like the solvers. The predominant interface, of course, we try to define our APIs using the proto, which kind of makes us language independent in a certain sense, apart from when you come to implementation details. However, C++ is quite dominant there, and Python is actually quite dominant. So where does that leave Julia? We have these like small, I'd call it small because it is small, but it's growing, like a small Julia group that tries to work on Julia stuff within the scope of Google. Let's just try and either add wrappers onto them to try and make Julia more active. I'd say it's kind of growing, but we still have some way to go in order to get like a critical mass such that Julia might be probably considered as one of the go-to languages for certain use cases or certain problems within Google. Yeah, I think the buck stops with us. If you write Julia, try and push for it, something of that sort within the organization. Yeah, but at least I'd say we've kind of progressed very well, especially with the OR tools. The OR team is quite receptive to Julia, given their knowledge of how impactful like Julia users are to like mathematical optimization. So they are very receptive to that. That I can tell you. Yeah.
Gotcha. Thank you.
Cool.
We got time for another question, or perhaps two, if we've got. I've got a very quick follow-up question to that, which is no, it is far less serious than the last question, but in some sense a lot more serious. So I never thought before about the Julia color scheme versus the Google color scheme, that you've of course got the red, the green, and the blue in common, and then differing in the purple versus the yellow.
Yeah.
How close are the Google red, green, and blue to the Julia red, green, and blue? Have you ever given this any thought? I never thought about this until your title slide, where both logos were up side by side.
Really? I didn't even notice that, man. Okay.
Yeah, they're quite similar. So in terms of the future of Julia at Google, or Google tools for Julia, there's some thought about what the closest matched color palette would be. Yeah.
I don't have any thoughts on that, but maybe I should think about it and get back to you.
More of a comment than a question, I suppose.
Pardon?
more of a comment than a question, I suppose.
Okay. Yeah. Now that I look at it,
they're awfully similar.
Yeah, with a slight difference in the amber, but you're right, man. In the purple. Yeah. Cool. Yeah.
Thank you. We've got time for another question. We've got one in the audience. All right, well, seeing none others, let's have another round of applause for Ochibobo. Thank you very much.
Thanks a lot, man.